Okay, so remember, to find the trapezoidal, using the trapezoidal rule, I'm just going to divide this thing up into certain trapezoids, and we're going to calculate the area of the trapezoids and so on and so forth. So here's how this works. Delta x is equal to 1 over, let's actually b minus a over n, all right? And so we're given that b is equal to 2, a is equal to 0, and n is equal to 4. So then delta x is going to be 2 minus 0 all over 4, which is 1/2 or 0.5, right? 2 over 4. Does that seem right? Yeah, it's 1/2. So delta x is equal to 0.5. And we'll use that in a second here. And now for the trapezoidal rule, remember, we would start evaluating. In other words, our domain would be 0. Then we would say 0.5. Then 1, 1.5, and then 2, 2.0. Okay? And so we have this parabola that kind of comes through here, and we're going to evaluate from here to here, which is, this is 0, this is 0.5, then we're going to evaluate it at 1, evaluate it at 1.5, and then evaluate it at 2. And so we're going to have a little teeny tiny trapezoid here, then we're going to have a bigger trapezoid here, a bigger trapezoid here, and then one trapezoid here, and we're going to sum all those up. So to find the trapezoid, the formula, remember, is going to be, in this case, it would be, let me write down the formal definition of the trapezoidal rule so that there's no confusion about it. And so this is also referred to as H. So for the trapezoidal rule, I'm going to get the area of the trapezoids. Let me put that in a darker color. The area of the trapezoids is equal to H divided by 2 times, in this case, we're going to have y naught plus 2 times y1 plus dot dot dot. And the last one is yn. So we do 2 times everything. Now, h is 1/2. 1/2 of 1/2 is 1/4. So we get the area under the curve is 1/4 times f of 0. Okay, plus 2 times f of 1 plus 2 times f of, not 1, it's 0.5, I forgot. F of 0.5 plus 2 times f of 1. That looks bad. 2 times f of 1 plus 2 times f of 1.5 plus 2, or f of 2, because you do the very last end. F of 2, and this is f of 1. Okay? And so to do that on the calculator, that's not that hard to do. I'm going to pull up my calculator, and let's graph this. So we're going to hit clear, and we're going to graph 2x squared, and hit graph. Now the next thing I'm going to do is I'm going to hit second window. I'm going to start at 0, And then I'm going to set this at 0.5. So I'll get all my tables right here. So basically, my values for that are going to be the area under the curve is 1/4. F evaluated at 0 is 0 plus 2 times F evaluated at 0.5 is 0.5 plus F evaluated at 1 is 2, so 2 times 2. And then F evaluated at 1.5 is 4.5, so 2 times 4.5. And then the last term, F evaluated at 2, is 8. Is that right? Yep. Now, I'm going to plug those in. Let me clear this out. So I'm going to say 0.25, start my parentheses, 0 plus 2 times 0.5 plus 2 times 2 plus 2 times 4.5 plus 8. Close my parentheses, double check my work. 2 times 0.5 plus 2 times 2 plus 2 times 4.5 plus 8. And I get 5.5. So then t equals 5.5. Alrighty, that would be the same as 11 over 2. Yep.
I have a question.
Yes.
How does Grant plug in like the air, like he does like the area under the curve and he just plugs in the numbers in the calculator? How does he like get to that?
He may have a program. There are some programs that you can plug in and it'll automatically do all this. So there's you could download a program and you say trapezoidal rule and you put in B and A and then N and it automatically does all those. He may have downloaded that. And you can do that. I just want to teach you guys how to do this first.